Okay, so in this problem here, we have Noodleman noodles, and they make it, as you can guess, noodles. Each pack of noodles advertise a weight of 15 ounces. Noodleman recognizes that each pack won't weigh exactly 15 ounces, but believes the noodle making machine is calibrated so most of the packages are 15 ounces. If the packages aren't 15 ounces, then Noodleman will have to shut the factory down and recalibrate the noodle machine, which is an expensive proposition. To decide if they need to shut the factory down, they take a random sample of 88 packages and weigh them and find that the mean of the samples is 14.87 with a standard deviation of 0.58. If they don't have 15-ounce packages, they run the risk of a lawsuit for making false claims. State the null alternative hypothesis. Well, it's quite clear that the null hypothesis for this scenario is going to be that the mean is equal to 15 ounces. Where the alternative hypothesis, though, is not actually talking about less than or greater than, but it's actually talking about not equal to. Because it says if the packages aren't 15 ounces, that doesn't talk about higher or lower, it just says is not 15. So I am going to put bigger than or equal to, what am I saying? Not equal to 15 ounces. So here are our null hypothesis, and mu is equal to the mean weight of noodles. Okay, and so I am planning to use a 1 sample t interval because it says to do a t interval here. And the degrees of freedom, well, they're going to be 87 packages. Okay, so will the central limit theorem be used in this problem? And the answer for this one is yes, because we know we have this great big giant population of noodles, and we're taking a sample of 88 of them. And then we make a model of the sampling distribution. And then we make a dot. And that dot represents this normal curve represents all the different groups of 88 packages. And that's what we're looking at. And so the standard deviation will be the standard deviation over the square root of n. And so we are using the central limit theorem in this particular case to solve this problem. And even though I said normal, it's really going to be actually the t interval, but they're, in essence, very close to being the same thing, and conceptually, they really work the same way. So yes, we'll use the central limit theorem. So then it says, determine the Noodleman height, what is going to do, use a confidence interval to test the hypothesis. Well, I know that n is going to be 88. And x bar, I know, is going to be 14.87. And my standard deviation of this sample is equal to 0.58. We have to recognize that this is sub n. We need the unbiased estimator. This is biased because it's the actual standard deviation of the sample. So in order to do it, I'm going to go and convert it. And it's going to be the square root of n, which is 88 over 87 times, I don't need to put underneath the square root, times the biased, which is 0.58. And so going to my calculator, I can see that I'm going to go divide 87 times 0.58 gives me a very close standard deviation, 0.5833. Okay, and I'm going to store that into A. I'm going to store it into A so that I don't have to type all those values, and I'll be more accurate. So to make my confidence interval then, I go to stat, I'm going to calculate, I'm going to do I believe number 8 is a t interval. I have statistics. I know my mean is 14.87. My standard deviation is A. My N is 88. And alpha is 0.05, which corresponds to 0.95 as a confidence level. And I get this particular confidence interval, I get 14.746, comma, 14.994. And so based upon this, what I can say is, therefore, 15 ounces is not in the interval. So we reject H naught and say sufficient evidence to claim the noodles are not 15 ounces. Okay, and so we've done a hypothesis test where we've used the confidence interval as opposed to a p-value. We found our unbiased estimate of our standard deviation. We got our numbers, and so we're good using the central limit theorem, and we have our null term hypothesis. And then finally it says discuss the implications of a type 1 and a type 2 error in this context. Well, to introduce you to the idea of a type 1 error, type 1 error is if you reject H naught, but you should not have, So it should not have. So in this case, we actually rejected H naught. So we may have committed a type 1 error. We'll never know. And so if we'd made a type 1 error, we rejected the null hypothesis and claim we have to, the noodles are not 15 ounces. And the consequence will be, if it's an error made, we will recalibrate the machine, that doesn't need it. Hence, spending money. Money is spent without cause, okay? With no cause. Type 2 error, which in this case, where there's no chance of that, is when you fail to reject, but you should have rejected. And that consequence in this case would be opening up to a lawsuit, as you're making false claims. All right, and so here's confidence interval using a t interval to calculate whether Noodleman is making good noodles or not.